Welcome to the end of the world. At least that's what happened 66 million years ago, directly that way, a little under 100 miles away. You can probably guess what happened here at 66 million years ago if you kind of know that number. And an asteroid about 6 miles wide came down from about in the springtime, about from a 60 to 45 degree angle. Not insanely quickly, but pretty quickly. I forget exactly how fast. It's I think it was like 100 miles a second or so, somewhere in that time frame. But you'd see it come across, and it would have instantly vaporized an area several miles across, and then sent out about a mile-tall tsunami moving over the speed of sound, so around 1,000 miles per hour, out in every direction. And that was the end of the dinosaurs. Now, how do we know this? Well, back in the late 70s, this father-son team called the Alvarezes, Louis and Walter Alvarez, one was a geophysicist, the other was an astrophysicist, came up with this hypothesis that an asteroid killed off the dinosaurs. And they had discovered this unusual mineralogy in rock layers over in Italy, I think, called iridium. And then later on, some other scientists found other stuff, and the evidence started piling up to suggest that an asteroid hit the Earth at about 65, 66 million years ago. But they didn't find the crater. Their hypothesis was pretty much accepted as a pretty good theory, because we found all this other evidence right at this time frame in the rocks all across the planet. But they didn't have a crater. Well, in the 80s, these guys were drilling out here in the Gulf of Mexico, just north of the Yucatan Peninsula. And they drilled through some unusual things. They were looking for oil and gas, and they drilled through some melt breccias, basically some what kind of looks like volcanic rocks, but when you study them a little bit further, you realize they're not quite volcanic rocks, they're something else. And what that was the remnants of that asteroid hitting and melting things and getting preserved quite a ways down into the Earth. Now, where's the crater today? I mean, you could say like, whoa, it's underwater, but it's not underwater. It's kind of half underwater and half on land, but even on the land, you can't really see it. There's hardly anything left of that crater, and it's because 66 million years is a good bit of time for weathering and erosion to do its job. However, if you go out there with geophysical equipment and all the fancy toys and technology that the oil industry has, you can actually see a lot of evidence of where this crater is and exactly how big it is. And it's around one of the second largest craters we've ever found on Earth, I think, depending on what you call a crater and what you don't, and how certain we are about some of them. So there is one that's even bigger. But yeah, can you imagine? A mile high's worth of just white water just racing at you at 1,000 miles per hour, faster than a passenger jet. Now, it's not insanely fast, right? That's not like blink of an eye fast. So you kind of could have, even though I'm only 80 miles away or so out there, you could have watched all this happen. You could have seen that streak come down that 6 mile wide fireball, and would come right across this way from the northeast. Would come straight down, and boom, and then out comes the tsunami. It would have been a really bad day. And I'm actually within the area where the ejecta, all the material that it kicked up, the bottom of the ocean's not super deep, and it kicked up all of that material, all of that geology, and it came raining down in this area really heavily. Threw a lot of material up into space, through all this ejecta and tektites and everything, all across the Earth, probably caused, not probably caused, we have a lot of evidence that it caused forest fires all around the planet. Just a really, really bad day, killing off about 75% of Earth's species at that point. I won't get too much into it, but we do know now that there was another side to the dinosaur extinction. It wasn't just this impact. In fact, we've had impacts like this throughout Earth's history, and they don't really have extinctions to go along with them. So it's like, why did this one cause an extinction, but some of the other ones didn't? Might have something to do with where exactly this hit, the kind of geology that it hit, kicking up sulfates and everything, and just making the climate change worse at the time from it. But we also know on the other side of the planet in India, there was something called the Deccan Traps. And this was extreme volcanism that was occurring, that was already causing a lot of problems, a lot of climate change at the time. So things were already kind of on the struggle bus in terms of life surviving, and so it was already under a lot of hardship. And then this is kind of a kick you while you're down kind of thing. Now, had this not happened, would the dinosaurs have survived? Yeah, probably a few of them would have, and frankly, some of them did anyway, right? The birds are dinosaurs. I own chickens. If you watch chickens long enough, you start to realize, okay, yeah, those are little velociraptors running around. They don't just eat seeds and bugs. I've watched them grab a chicken and chase each other around like it's a little football or something. Anyway, but yeah, there it is, out there, just beneath the water. The end of the world.